Start, sir.
Okay. Good morning. Welcome to all to the webinar classes TRE Society Hyderabad. This is physics second year class. We are discussing about wave optics. In this wave optics, for the last previous classes, we have studied about different theories of light propagation, that is corpuscular theory and wave theory. And also we have proved wave theory is better than the corpuscular theory by velocity of light, the main factor velocity of light. Based on that, velocity of light in denser medium is less when compared to that of rarer medium. By this statement, we can give the clarity about the theories which are already existing, Newton theory and this Huygens wave theory. Based on that Foucault experiment, it was proved velocity is less in denser medium, and after that completely the corpuscular theory is not accepted by scientists. From then we are believing, we are following wave theory of Huygens. So based on this, we have explained refraction and reflection of light, how refraction takes place and how reflection takes place on the basis of wave theory. And next, we are going to see some important topics that are most important one, that is redshift and whiteshift, that is Doppler effect. In the last class, we have discussed Doppler effect. As in the case of sound, the Doppler effect we can observe in case of light also. But here the important factor is the velocity of light is very high. That's why we can't easily identify this Doppler effect. But astronauts in the astronomy, it is most important. In the astronomy, they will take this Doppler effect factor, and by this redshift and blue shift, why it is the stars are moving away and moving towards the observer, how they are changing the wavelengths and frequencies we are discussed in the last class. And also in this, we have discussed coherent and incoherent waves. What is coherent wave and what is incoherent wave, and all this. The main feature of coherent wave is two light waves with the same frequency. The most important one is two sound waves, that is two light waves with same frequency. And the important thing here is the phase difference with the time is constant. Always the phase difference is constant. Now we are going to see theory of constructive and destructive interferences. What is interference? Before going to see, we are discussing this. Coherent and incoherent. If there is no phase constant between two light waves, that is incoherent. Frequency is same. Coherent and incoherent, frequency of waves is same, but the main difference is the phase difference. Constant phase difference maintained. In case of coherent waves, there is no constant phase difference between two waves in case of incoherent waves. Now, this interference takes place in coherent waves only, not in incoherent. But you can observe in incoherent waves, but it is not, intensity is very less. In incoherent waves, we can see this interference, but in case of coherent waves, we can easily observe it. Now, let us see what is constructive and destructive interferences. When there are two light waves are combined each other, the effect is, we are discussing, that effect is interference. Simply, we are talking two light waves superimposing each other, then what happens? Interference takes place. Before going to details about that interference, while two light waves are combining, sometimes there should be constructive and sometimes there should be destructive interference. As in case of transverse wave, crests and troughs are alternatively forms. Similarly, two waves are superimposing, destructive and constructive interferences takes place. How these interference takes place, we will discuss mathematically here. Consider two coherent sources. Let us consider S1 and S2, which gives waves to angular frequency and wavelength lambda and amplitude A. Both these two are same amplitude, same frequency and wavelength. Those are coherent light sources. So we are giving those. And now if a point P is equidistant from S1 and S2, let us imagine two S1 and S2 are separated by a small distance. Now these two light waves are away from a screen at P. Now the path difference between the distances traveled by the waves here, let us consider S1P, how much distance it is, minus S2P. Both these two are 0. S1P minus S2P is equal to 0. Why? Because both these two are equal. The displacement of the waves from the sources, let us consider Y1. Y1 means S1 waves. Y1 is equal to A cos omega t and Y2 is A cos omega t. Both are same equations we have taken. Why? Because there is no phase difference here. That's why we are taking same equations. One is Y1, one is Y2. The resultant displacement is Y1 plus Y2, combining these two. So A cos omega t and A cos omega t. Y is 2A cos omega t. The amplitude doubled. Here you can easily see amplitude. What about intensity? What about intensity? Intensity exactly doubles the amplitude. I is equal to A square. We know it. Therefore, amplitude is double means 4 into I0, where I0 is intensity of each wave. So 4 times intensity increases. From this equation, when there are two coherent light sources combining, then we can tell that intensity increased. Now, how does it increase? Let us see. The resultant intensity becomes maximum when it is 0. We know S1P minus S2P, just we have seen it is 0. 0 means both these two are in same phase. Not only that, both these two gives same waves, number of waves. So the number of waves here we have taken n lambda. Generally the distance we take as lambda. So n waves are there. Each wavelength is lambda. If there are n waves between n1p and n2p, both these two, n lambda, n you can give 1, 2, 3, 4 and so on. If you can get this n lambda, the difference between S1p minus S2p, which we call it as path difference. Path means distance. Path difference is equal to exactly multiples of these lambdas. How many waves are produced? For example, in one wave there are 4 waves. S1 produces 4 waves. So what is its length? 4 lambda. If S2 produces 6 waves, the length is S2p, we call it as 6 lambda. So difference between these two, 6 lambda minus 4 lambda, you can get 2 lambda. So n here 2. So this is called constructive interference. Exactly the multiples of 0, 1, 2, 3, 4, 5 of lambda, that is called phase difference. How much it is the phase difference? Phase difference means angle. When you take angle for lambda, exactly lambda is completed one wave, phase is 2 pi. You should remember lambda is 2 pi. N lambda means you can take 1, 2, 3, 4, 5 and you substituting n, 4 lambda, 5 lambda, 6 you are writing. So according to that, 6 lambda means what is the phase? 6 into 2 pi. Each lambda is 2 pi. Like this, the numbers 0, 1, 2, 3, 4 and so on, if you are writing n, exactly you are getting number of lambdas or phase difference is 0 or 2 pi. Why you are writing 2 pi? 0. 0 means, for example, S1 produces 4 waves. So S1p is 4 lambda. S2 produces 4 waves. Therefore, S2p is also 4 lambda. So S1P minus S2P, how much? 4 lambda minus 4 lambda, which is equal to 0. Therefore, in that case also, okay, in that case also, it is called constructive interference. So we are talking here in terms of phase. Phase means in terms of angle and in terms of path. Path difference means we have to talk in terms of lambda. Phase difference means you have to talk in terms of pi, angle. Okay, lambda is equal to, what is the phase? Path difference lambda is exactly 2 pi. You remember that. 2 pi is equal to lambda. From that you can convert any number of lambdas are there. So if it is path difference, directly you can measure the distance. Path difference means that path difference is 0 or n lambda. Then it is called constructive interference. What does it mean? Exactly when there are two waves are combining, one wave at an instant of time in S1 source produces a crest. As with respect to transverse wave, easily you can understand. S1 produces crest. What about S2? S2 also produces crest at the same time. Both these two, one already produces crest, S1. So the particle moves at an amplitude of A1 due to this crest. S2 also at the same time produces another crest. So here, what about this particle? Particle received amplitude doubles. Whatever the amplitude already has the first one, S1 produced wave, it is in crest condition. Second wave also coming at the same time, the same particle has in crest position. So combining effect, it is already a certain energy. When it is in crest, it has energy. Okay, again S2 is also giving some energy. That is S2 gives energy, double its energy, A1 plus A2. Therefore, a maximum crest is formed. That is called, we are telling it is constructive interference. When the wave is going on, crest and troughs continuously going on, how many times does the maximum amplitude takes place? That maximum amplitude consecutively in n lambda distances every time we can see constructive interference. And vice versa, what is the destructive interference? Quite opposite to that. Here, destructive interference means y1 plus y2, 1 in first wave, amplitude y1, and in the second wave, y2 is negative, means one is in crest, another is in trough. When at an instant of time, one S1 produces a crest with A1 amplitude or Y1 amplitude, and S2 produces Y2 amplitude trough. It is a trough, and that is crest. When crest and troughs are at a time acting on a particle which is in medium condition, then what happens? Upward or downward forces, F1 and F2 are acting on a particle. Then what is the resultant? F1, F2 are in opposite direction. The resultant is F1 difference F2. So the minimum displacement takes place. This minimum displacement is less than Y1. This minimum displacement is less than Y2. Understand? So the resultant displacement is less. Here, in case of destructive interference, Y1 is taken as A cos omega t and Y2 is taken as A cos omega t minus phi. Why we are taken this minus phi? Second wave, one is in crest condition, another wave is in opposite trough condition. So what is its phase? When is in trough and crest, the exactly opposite point phase difference is pi. Therefore, we have taken A cos omega t minus pi. So what is the resultant here? Y is equal to A cos omega t minus A cos omega t. So we are getting 0. The displacement becomes 0. While displacement is 0 means what is it? It is called destructive interference. So the resultant intensity becomes 0 for the path difference. When it is while we are talking about path difference, what is the condition of lambdas? If you are talking about lambda, exactly it is lambda by 2. The path difference we are talking, it is lambda by 2. So when it is lambda by 2, then in terms of pi, how many lambdas we have taken? In previous n lambda, that is called, we are talking, it is n lambda means constructive interference. Now, what is this destructive interference? When destructive interference takes place, 2n plus 1 lambda by 2, easily you can write 2n plus 1 or n plus lambda by 2. n plus lambda by 2 is the phase difference we are talking about. N plus lambda by 2, that n is 0, 1, 2, 3, 4. If the path difference is in terms of negative lambdas, for example, in terms of 3 lambda, 5 lambda, 7 lambda, 9 lambda, like this, while lambda by 2, 7 lambda by 2, 5 lambda by 2, while you are taking n plus means n you can take 0, 1, 2, 3, 4 and so on. If you are taking 1 plus lambda by 2, how much it is? 3 lambda by 2, 5 lambda by 2. Whatever you are substituting, if you are substituting 3 means what is the lambda? 7 lambda by 2. And if you are substituting 4, 9 lambda by 2, like that, odd numbers of lambda by 2, you are getting destructive interference. Crest of one wave adds up to trough of another wave to get 0 amplitude and 0 intensity. Intensity is almost 0. That's why intensity 0 means in terms of light waves, you can see a dark region where intensity is doubled, 4 times it is increased, as in case of constructive interference. What does it mean? How you can identify on the screen when two waves are superimposed each other, and due to interference, there you can see a bright fringe, and here destructive interference is dark fringe. See this diagram, easily you can understand what is constructive interference. One, you take a green wave and a blue wave, S1 and S2, green and blue I have taken. To understand it, what is the resultant of these two? That is, the red wave is the resultant. You see, in green wave, there is a crest, and blue wave is also a crest. Similarly, when blue wave get trough, green wave is also at the same time it get crest. So combining these two, constructive interference takes place. In the down, you can see destructive interference. In the blue wave, blue colored wave, you can see that is crest, and here in the green there are trough, and crest and trough exactly opposite to that. What about the resultant red line? Red line is almost a horizontal line we are showing here, almost 0, resultant 0. So due to destructive interference, we can get 0 intensity, means we can get a dark fringe. And due to constructive interference, we can get bright fringe. When two light waves are mixed and keep a screen at a certain distance from these sources, we can see on the screen a dark and bright fringes alternatively. Dark and bright fringes forms on the screen alternatively. This phenomena, forming these bright and dark fringes, this phenomena is called, we call it as interference of light. Interference of light. See, in this diagram also the same, wave 1, wave 2. Both these two are combining, how these two are combining, and what is the wave 2x. You can see with respect to amplitude, I want to explain you. X and x, that is the amplitude of wave 1 and wave 2. What is the resultant? X plus x, that is 2x. In the second B diagram, you see x and x, but here wave 2 is quite opposite to wave 1 in phase. Phase exactly, phase difference of wave 1 and wave 2 here, it is in the B diagram, it is exactly pi, where 1 is crest and in the wave 2 is trough. And combining those two last 0, we are showing that 0, 1. Now, can you understand? I think all of you understand how these fringes are formed due to interference of light. The next most important experiment conducted by Thomas Young. Young's double slit experiment easily demonstrates this interference. Even though this is the theory involved in the interference, you can understand what is interference and how does bright and dark fringes are formed. The light waves coming out from two independent sources of light will not have any fixed relationship, would be incoherent. We have already talked about what is incoherent. The light waves coming from two sources, you tell only these two are incoherent. There is no phase relationship. Fixed phase relationship is there, then only they are called coherent. Okay, according to theory, it is okay. When there are two switches, 40-watt bulb and 40-watt bulb, I have taken and switched this. These waves are coming from this light bulb, even though these waves are not coherent. According to our definition, what we are talking coherent means the light waves should be in the same phase, but it is not easily you can form coherent waves. So why the importance of Young's double slit experiment? What is the importance of this means? He produced coherent waves. He produced coherent waves with the help of a single wave, single light source. We are using only single light source, but he converted this single light as two coherent light waves. That is a technique of Young's double slit experiment. Thomas Young, the British physicist, used an ingenious technique to produce two coherent light sources with a constant phase difference, what we have discussed earlier between two sources. He used, how he have produced these? He used two pinholes, S1 and S2. A cardboard is taken very closely. If distance is increasing, it may be changed. That's why a certain very small distance, S1 and S2, we have to take two holes, each other, an opaque screen. These are illuminated by another pinhole that was lit by a bright source. S1 or S2 are illuminated by another light source. Thus, the two sources, S1 and S2, act as coherent sources. Why? Because the same light coming from S. S means, let us take illuminated source. The light is coming from S at a time falling on S1 and S2, and light comes out from on S1 and S2 at a time. When the time is constant, at a time two sources are produced with the same wavelength and same frequency. Understand? Frequency, wavelength are equal. Why? Because same light are used as S. S, for example, sodium vapor lamp. According to sodium vapor lamp, it has a lambda. The same lambda comes out from, same lambda of waves comes out from S1 and S2. So lambda is same, wavelength equal. And frequency is also same. We are not sending S1 and S2 in different times. At a time, S1 and S2 comes out. So the waves produced from S1 and S2 are same phase, are at constant phase maintained throughout its journey. Understand? So you can see formation of interference fringes. You can see what I am discussing here. You see in this diagram, S is the source. Here, to understand experimentally, to give same intensity of light, we are using a convex lens also. You can use from this lens a parallel beam of light may fall. Otherwise, the intensity may slightly changes coming out from S1 and S2. Therefore, to give that, we are using this lens also. So S1 and S2, you can see PQ is the screen placed at a certain distance from S1 and S2 sources. So according to Huygens wave theory, from S1 is the source, we can see as a center, S1 is the center, a circular wave fronts are produced. Circular wave fronts, one type a dark line, another a dotted line. What does that mean? Dotted line indicate trough, dark line crust, crust trough. Like that, a transverse waves are produced from S1. In the below S2 also same, a dark line and dotted lines they are drawing. Whenever two dark lines are combining or two dotted lines are combining, you can see bright maximum amplitude. You see maximum, minimum, maximum, minimum, maximum, minimum. We are writing on this PQ. What does it mean? The minimum means at the upper adjacent to this, we can see minimum means dark band, dark fringe forms. Maximum, where the points joining blue, here shown in the diagram, you see carefully, blue colored dots placed at maximum and red color dots placed for minimum. Where is the red color? One crest and another trough. When these two are joining, crest and trough means dotted lines are dark line joining. You can see dark lines, and where forms maximum means two dotted lines are two dark lines, means both these two are in same phase. When these two are joining, you can see a bright light due to constructive interference takes place. Dark places, dark bands formed due to destructive interference. This is formation of interference fringes, dark and. Now let us see expression for fringe width. Here some geometry we are using now, that is the experimental setup we have seen. This is geometry. S1 and S2 are two light sources at a distance of D. And now a screen is placed before that at a distance of capital D. Capital D indicate distance from source to the screen. Small d indicate distance between two light sources S1, S2. Now, from S1 and S2, at point P on the screen, we can see a constructive or destructive interference. Whether it may be constructive or destructive, whatever it may be. A bright fringe is formed at P. Let us take. What is the distance from the center? O. Yeah, O is exactly equidistant from S1 and S2. Understand? That's why we have taken O point also. From this O point, the P we have considered at a distance of X. Why? Because what about CS1? CS1 is exactly D by 2 and CS2 is D by 2. So this diagram is very important for deducing expression from fringe width. Our aim is to calculate what is the width of the white fringe or dark fringe. So to start this, we will see some what we have shown in the figure. The spherical wave fronts emanating from S1 and S2 will produce interference fringes of bright and dark, equally spaced. That is most important, equally spaced. There is one word, bright means that breadth is more, dark means that breadth is less, is not correct. Both formed equally. Why? Because that also we will see here, that whether both these two are in same phase, both crest and troughs and both troughs amplitude and crest amplitude are equal. That's why here the fringes are also equal breadth on the screen placed at a distance D from the slit. The bright fringe correspond to a point on the screen due to Bright fringe due to constructive interference. Let us take at P point, we have considered a constructive interference. Now, what is the path difference? Path difference means nothing but distance difference. S1P minus S2P, or you can write S2P minus S1. That symbol is a difference. Whether you take S1 down or S2 in up, you can write S1P minus S2P, or you take S1 down, S2P down, then you can use S2P minus S1P, whatever it may be. That is called difference. Is n lambda. Why you are writing n lambda? It is constructive interference. A bright fringe is imagined. So n is 0, 1, 2, 3, and so on. The dark fringe correspond. If there is a dark fringe, not it is, for example, at the P point, it is dark fringe n, then you have to take that value n plus half lambda. Now, you see this diagram from the figure, we are going to see S2P square. Why I am taking S2 down? So S2P is greater than S1P. So to get positive value, I am writing S2P square minus S1P. It is small when compared to S2P. The square we have to write. S2P square minus S1P square. What is S2P square? You construct a right angle triangle. You see a dotted line with POC. Just you can take POC. In that, just you CO is taken below to S2, then P S2, and below S2 we have to take one point. On the screen we have to take another point. So we will see this in the next class. The time is over. That's why tomorrow we can discuss about this fringe width derivation. Okay, thank you for